Yes, sir. Sir, but I can't write it on it, sir.
That's why I want to make it as a presenter.
Yes, sir.
You try to share your screen.
Done, sir. Sir, can you hear me?
Yes. Yes, we can.
Good afternoon, everyone. Today's my topic is master slave JK flip flop. So in to go with master slave JK flip flop, let us learn about the concept called racing and toggling. In racing condition, suppose if we take SR flip flop, in this, if you see if S equals to 1 and R equals to 1, suppose in the case of S equals to 1 and R equals to 1, according to the truth table of SR flip flop, we get the output as forbidden state. So to avoid this forbidden state, we'll go with JK flip flop. In JK flip flop, now to avoid this forbidden state, we will be attaching the feedbacks in JK flip flop so that this forbidden state will be avoided. Now, if you see that if j equals to 1 and k equals to 1 and if clock equals to 1, there will be the continuous change in the outputs. So this condition is called racing condition. Whereas coming to toggling condition, for SR latch, if we attach T, then it is called toggling state or toggling flip flop. So in this toggling flip flop, here will not see the continuous change in here will not see the continuous change if suppose if the input is 1, then here only one input will be changing. If a clock is high, then the input will be changing. In all other cases, the input will be memory. This is called toggling state. Now master slave JK flip flop. So in JK flip flop, as we see the racing condition. So to avoid this racing condition, we'll use master slave JK flip flop. This is the block diagram of master slave JK flip flop. Here master flip flop and slave flip flop. There will be two flip flops. These will be arranged in series. And here this will be arranged in series. And the clock is connected. Here the negation of clock is connected to slave flip flop, and um, as we see in JK flip flop, the output of JK are connected as feedbacks. Whereas in master slave JK flip flop, the output of slaves are connected as feedbacks, and here the Q1, the output of master flip flop, as taken as input to the slave flip flop, and here clock is connected in the negation, means we are applying not gate here. So in this we have conditions like if we see if j equals to 1 and k equals to 1 and clock equals to 1. Here if j equals to 1, clock equals to 1 and k equals to 1, what will be the output in the truth table? According to truth table of JK flip flop, if j equals to 1, k equals to 1 and clock is high, then we'll get Q1 is the output of master flip flop. So if both three cases are high, if three inputs are high, we'll get active state here. As it clock is high, it is connected to NOT gate, to the slave flip-flop. Now here you will take clock as 0 and S is equals to 1 and R is also equals to 1. Then if S equals to 1 and R equals to 1, according to JK flip-flop, here the output will be memory, which is not changing. So here, what is the racing condition? In racing condition, there will be continuous change in the outputs. Now, if we observe, here the output is memory. So there will be no continuous changing of outputs. So here racing condition is avoided. So this is the first condition to avoid the race. Next, second condition. Let us go to the second condition. If we go to the second condition, now same, let's take j equals to 1, clock will be 0 and k will be equal to 1. If j is equals to 1, clock is 0 and k is equals to 1, then here as q1 is output of the master flip-flop. When q1 is the output of master flip-flop, then what will get here? q1 will be in memory state. Memory state. Now, as clock is 0, when we go to the slave, here the clock will become 1 and S is 1, R is 1. If we take all 1, then the output Q will be
Active.
active. As here in master flip-flop, if the output is memory, there will be no change, right? No change in the outputs. If there is no change here, as Q is connected as a input to slave flip-flop, then slave flip-flop will also undergo no change. Here, racing condition is avoided in this way. These are the conditions. Next, clock diagram. This is the normal clock where this is 0 and here it is 1. Again this is 0 and here it is 1, as we all know. Now J and K we are taking as 1. So this will be J and K line where J equals to K equals to 1. So this is the output. You can write it as Q1, no issue. So this is the output of master slave. And this is the output of master and this is the output of slave flip-flop. So first master flip-flop, first we took clock as 1. So starting from 0, first we took clock as 1, so it started raising. So from here, these are the points of triggering for master flip-flop. So first it is 0, then as this clock started raising, these also started raising. As we took clock as 1, it is in the active state, so it started raising. Till the complete clock, it starts raising. It remains same, raising, till we complete one complete cycle. Again, it's falling. This is due to inverted condition. Till the complete clock, it starts falling again. It will be continued falling. Again, it started raising here. So, it started again raising. Again, if you invert it till the complete clock, it will be raising. Again, at this point, if you invert it, it starts falling. This is master slave. Sorry, this is master flip-flop. Clock triggering. Whereas coming to slave flip-flop, now in slave flip-flop, we applied inverted clock. So till inverted, it will remain 0. This triggering. Now we apply this triggering. Till it is inverted, it will be in 0 state. When the clock becomes high, then it starts getting high till the complete cycle. Till the complete cycle, now it gets high. Next, now it started falling. Now after falling, it will be 0 till the complete cycle. It is 0. After that, it started raising again. Till the complete clock, it will be raised and it continues as this follows. Now, in order to know, we used which clock, like edge, level, negative or positive. Now, by seeing this diagram, we can say that we used negative edge triggering. As you all see, the output is QS. In QS, as we all see, here the triggering starts in downward direction of this clock. If it is downward direction, then this is negative triggering, negative level triggering clock. So by this we can say that here we use negative level triggering clock. Thank you. Done, sir.
Okay. Any doubts in this?
So what is active, sir?
Yes, ask Rishika what is active.
Active means it is 1, sir. In high
Same as
output.
low and high.
We can take it as low and high, active and memory.
Thank you.
Okay, so if you take here clock, what kind of clock is this?
Level trigger.
Level trigger, you are applying level trigger. So suppose if you take clock is equal to 1, then which one will function? Master or slave?
Master.
Master will function. So that's the reason you are calling it as active. And what will happen to slave?
It is inverted.
Memory.
Slave will be in off condition. So that's the reason you are calling it as memory. Why? Because it will hold the previous information. Next, suppose if you take clock as 0, then what will happen to the master?
It will become memory, sir.
It will become memory. Why? Because it will be in off state. Whereas slave will turn on. So that's the reason you are calling it as active. Next, what about this clock? You are going for level trigger. So if you take this as a clock, and here the default condition is j is equal to k is equal to 1. So when j is equal to k is equal to 1, according to the truth table, what will be the output? From the truth table of JK flip-flop, if j is equal to 1, k is equal to 1, output is Qn bar. So see here, initially you are assuming the value as 0, and whenever this clock is high, this is changing from 0 and it will be 1 till here. Okay. Now, suppose if clock is low, what will happen? Here this is for clock is equal to 1 case. We already know by default that when clock is equal to 0, it will be in previous state, which is nothing but memory. So if you observe here, when clock is low, what is the previous information you are storing till here?
Memory.
It is 1. This is 1. So you are carry forwarding this 1 till this point. Okay. Next, again, if clock is high, what will happen now?
Racing start.
Next state is nothing but complement. So till here it is 1. Now what will happen? What is the complement of 1?
It falls to 0.
Okay, it falls to 0 and it will be 0 till this point. Now clock is going 0. Now what will happen?
Memory.
Memory. What is the previous information that you have?
0.
0. So try to extend 0 till this point. Now tell me what will happen again when clock is high.
Racing.
So complement qn plus 1 is nothing but qn bar. So 0 will change to 1.
1.
1.
Till here it is 1. Now if clock is 0 again, should I
It
extend with 1 or
continues.
0? So you
Extend
have
1.
to extend this 1. Done. This is for master. But in the previous condition for the normal JK flip-flop that we have seen, when clock is equal to high like this, when clock is equal to high and j is equal to 1, k is equal to 1, output is getting changed continuously. But now here it is not changing. Can anyone tell me why?
Feedback connections.
Correct. Feedback connections. If you observe here, directly you are not giving the feedback connection from here to the input. In the middle, you are adding one more circuit that is called as slave. So when this is functioning, this one will be in off state. So this output will not be given again as an input. So that's the reason the problem of racing got overcome here. Whereas when master is working, slave will be in off state. Suppose if slave is working, this will be in off state.
Mastery.
Now can anyone explain me for QS? QS is nothing but output of slave. QM is for master. Now explain QS. So initially if clock is 0, you don't know, like you're taking value as 0. It can be 1 also. Now if clock is 1, what will happen? It will function for clock is equal to 1 or clock is equal to 0, slave.
0.
For clock is equal to 0, slave will function. So that's the reason there is no effect. You need to extend this 0. Now if you observe here, clock is 0 here now. So what will happen? It will change from 0
To
and
high.
it will
1.
be, so till this point it will be 1. Suppose if clock is equal to 1, here it is memory or will there be any effect?
Memory.
For clock is equal to 1, it is memory. So previously you are having 1, so extend 1 till this point. Now again if clock is equal to 0, so it should change. So it is changing from 1 and again it will go to 0.
0.
Again if clock is equal to 1, memory. So here memory is nothing but previously you are storing 0. So try to
0.
extend it. Okay, so what is the highlights now for master? For master, when clock is equal to 1, j is equal to 1 and k is equal to 1, qn plus 1 is nothing but how much? Qn plus 1 is nothing but qn bar.
QN.
If clock is equal to 0, if clock is equal to 0, what is
Memory.
happening?
QN. Memory.
Racing.
If clock is equal to 0, it will be memory.
Memory.
If clock is equal to 0, it is nothing but memory. Now tell me for slave.
The slave clock should be starting from 0. J equals to 1. K equals to 1.
Okay, j
Then
is equal
first
to
QN plus 1 will be memory.
for clock is equal to 0.
Yes,
For
sir.
slave.
Yes.
For slave.
Memory.
First slave it is memory. Then it starts racing.
For slave, when clock is equal to 0, it is memory. Correct?
Racing, no, sir.
What is racing? We are overcoming the
But
racing by means of this
change
master slave JK flip flop. So don't get confused with
active.
this. If you apply clock is equal to 1 here, this will be in active, this will be in memory. When clock is equal to 1, master is in active state, means it is functioning.
Slave is in memory.
Slave is in memory state. Suppose if you make clock is equal to 0, master will be
Memory.
memory now and slave will be in
Slave
active
will
state.
be
Active is
active.
nothing but it is working. Simply you can consider this condition qn plus 1 is nothing but qn bar here. Here also qn plus 1 is equal to qn bar. Whereas in the remaining two cases it will be memory. So at least this much if you need to know. And this is the default question. Without this question, he won't give the question paper. From unit number 4, master slave JK flip flop is mandatory. So that's the reason I asked Rishika to give the presentation. So default question. Either it may be for 7 marks or 10. Read this one clearly.
Answer. Thank you, sir.
So if everyone gives a presentation like this, it will be easy for revision. Tell me your doubts. Like some Mealy and more, you are having some doubt. Yes, Kirtana. What is
Sir,
your
must you
sequence?
explain the concept briefly, sir?
Means you want the state diagrams or else the entire concept?
Entire concept, sir.
Okay, so
State
before that,
diagram, sir.
we shall draw the state diagrams. So if you know the state diagram, the remaining concept is easy. So Kirtana, tell me your sequence.
So many states, sir.
Tell me your question. I think you have sent me some
One,
quick.
sir.
It is for 1 1 you want.
Yes, sir.
1 1 Mealy or more?
Mealy.
Using which flip flop?
JK flip flop.
Using JK flip flop. Okay. So Mealy 1 1. So how many states should I take for 1 1? How many bits are there?
2.
2.
So here 2 bits are there. So take 2 states. State is nothing but it is represented with a circle. And I'm taking state as A, this as B. Now I want for 1 1. So initially single variable can have how many combinations?
2
2
combinations.
2
combinations.
combinations. So initially if I apply 1, if I apply 1 to A, where will it go?
B.
If I apply 1, it is going to B and output will be 0. So here it will be got.
0. 1. Got 1.
So we are done with 1. Now for A, if you apply 0,
It will be near A only.
it will be in A only. So this is 0 by 0, which is got.
0. 0.
So we are
Sir,
done with
please
A.
turn up.
Now tell me for B. For B, if you apply 1, what will happen? If you apply 0, what will
It
happen?
will
So
be
simply write like this. This is nothing
applying
but 1.
0. It's A.
First tell me for 1 1. Got 1 1 case.
It will be near B only, sir.
Okay. So got 1 1 is not there. So remove left hand side bit. So got 1. Correct. It will be in B only if you apply 1. Output will be
1 by 1, sir.
0.
1 by 1.
Y 1 by 1.
Here the sequence is detected, sir.
Here the sequence is detected. So we need to take output as 1. Done. Now check for got 1 0.
It will go to B A, sir.
A. First
Okay.
we
Here
need
initially got 1 0 is not there. So left hand side
first
bit should be deleted. Okay.
next
It will go
we
to
will
A.
go to A.
So this is 0 by 0.
0 by 0.
This is the state diagram for Mealy 1 1 sequence. So once you know this, next what is the next step?
We have to draw the transition table.
Table.
Okay, tell me the format of the table.
Present state, next
Present
state,
state,
output.
next state, output.
Present state, next state and output. And Mealy depends on?
Both present state and present input. And state.
So this is x is equal to 0, x is equal to 1. Here also same thing. So we have present states. Two states are there. So that is A and B. So for A, if you apply 0. For A, if you apply 0, where it is going?
A.
Near A,
A
sir.
only and output is
0.
0.
0. So A by 0. So this is A 0. Again, for A, if you apply 1. For A, you are applying 1 now.
It is going to B.
B.
B. B
B
0.
0. Done. Next, tell me for B. For B, if you apply 0,
It is going to
It
A.
is going to A and output is 0.
so this is A,
0.
output is 0. Next, if you apply 1,
It is in B
B
and
1.
It is
output
going
is
to
1.
B and output is 1.
B and output is 1. So this is the next step. After this, what I have to do?
We have to check if the reduction is possible.
If reduction is possible or not.
So is reduction possible? How will you check?
If the
Next
next
state
state
and
and
output.
outputs are same, we have to
Reduction
do
is possible.
reduction.
They
Okay,
are
if
not
next
same.
state and outputs are same, you can remove one sequence or one row or one column. Okay, tell me now.
They are not same.
So if
Possible,
you
sir.
observe here AB is there, here also AB is there. But if you observe, outputs are not same.
Yes,
They are
sir.
different. So this third step is not possible.
Reduction state is not possible.
So state reduction is not there for this particular problem. Okay, next. After this,
State assignment.
State assignments.
State assignment. So everyone are doing a mistake in state assignment. So how many present states are there?
2.
2.
So my doubt is, can I give 0, 1, or else should I give as 0, 0, 0, 1? Which one is correct?
We have to
Zero.
give 0 and 1.
So
Zero.
0 and 1 is enough. So I'm assigning A is equal to 0 and B is equal to 1. So state assignment here, A is equal to 0 and B is equal to 1. So let me write here only so that later I can extend this table. So here it will be 0, 1. Here A is there. A is nothing but 0. B is nothing but 1. Now let us elaborate this table. So to elaborate this table, first take input, next present state, next state.
Take a flip flop.
So correct. How many flip flops should I take?
1.
One
Why
flip
only
flop.
1? Why not 2? Flip flop. What is meant by flip flop?
It is 1 bit storage
Bit
memory.
storage stores 1 bit of memory.
So it can store either 0 or 1. So if you observe here, either it can store 0 or 1. So only one flip flop is enough. And I'm taking output of that flip flop as Q1. So that next state will be Q1 plus. And input is denoted with X.
X.
So input and present state, two unknowns are there. So how many combinations?
0, 0, 0, 1, 1.
4.
1, 0, 1, 1. Now by seeing that previous table, you tell me the next states.
0.
0, 0, 1, 1.
Is 0, 0, 1, 1.
Sir, how did you take this, sir?
Okay. See here. For A, so now you have to consider A as 0. For A, if you are applying 0, what you are getting? Next state as 0.
0.
So for 0, if you are applying 0, it is going to the next state, which is nothing but 0. Next. Tell me for the next case.
A equals to 0. If A should be 1, no?
Now for A, you are applying 1, it is going to B, which is nothing but 1.
1.
So for 0 and 1 case, for A is equal to 0 and for X is equal to 1 case, output is nothing but B.
1.
So which case it is the second one, third one, or fourth one?
Output is 0.
For present state is equal to 0 and input is equal to 1. Output is
1.
Output is 1. Or else blindly we can write like this also vertically, like 0, 0, and it will be 1, 1. Now tell me for this case.
It is 1, 0.
For present state is equal to 1 and next state is equal to 0. For present state is equal to 1 and next state is equal to
0.
Next
so
state is
output
0. Output will be
Next
0.
state is 0.
output will be 0. And next case will be, this one will be 1. So blindly this will be the order 0, 0 and 1, 1 instead of checking all this many times. Okay, we are done with fourth step. Next, what is fifth step?
Okay, ma'am. Take a flip flop input, sir.
Choose the flip flop. Which flip flop you want?
JK.
You want JK. So again in the fifth step, again redraw this table. Means you write this table once again and add one more column called as flip flop inputs. So you want this one using JK. So you are having only one flip flop. So one input will be there, that is J1 and K1. Okay, next. After this, how should I fill this?
From the
Excitation
table of
JK.
the flip flop.
From the excitation table of JK flip flop. So inputs are JK. What is the relationship for excitation?
Q, Qn plus 1 and JK.
Qn plus 1 JK.
So output will be 0, 1, double X, and here it will be double X, 1, 0.
Double X, 1, 0.
Tell me outputs. How will you compare?
From present state and next state.
So for 0, 0, it will be 0x.
0x.
1,
1,
0.
0,
Don't
it is x1.
Don't care
Next.
1.
0, 1, it is 1.
1 don't care.
And don't care.
For 1, 1.
Don't care.
Don't
Don't
care
get 0.
don't care 0. Apart from this, we need to add the output also here. Output is nothing but Z. How will you write the output now?
0, 0, 0, 1.
So it will be 0, 0, 0, 1. This is 0, 0, 0, 1. Next, take the K-map for what?
J, K, and Z.
So do the K-map for J1, K1, and Z.
Z.
So how many variable K-map? 3 or 2?
2.
2
variable.
came.
Inputs are
X and
X
Q.
and Q1.
Q1.
X and Q1. So here 0 don't care, 1 don't care. 0 don't care, 1 don't care.
1 pair.
Next, X1, X0. Tell me the answers.
J1 is X.
J1 is equal to X.
K1 is X.
K1 is X bar.
K1 is X
K1
bar.
bar.
Z is XQ1.
Output equals
X
to
into
X into
X bar.
XQ. XQ1.
XQ1.
It is XQ1. Next, draw the logic diagram. Last step.
Logic diagram.
So J1, K1, Q1, Q1 bar. So what should be given for J1?
X.
X.
So it should be X. K is nothing but
X
X
bar.
bar.
X bar.
X bar. And how will you represent Z?
X into Q1.
So take one AND gate,
And get.
X and Q1. This is nothing but Z. Over. This is the final logic diagram for your Mealy sequence. So almost everything will be same. Yes.
If we take two flip-flops,
If you take 2 flip-flops, then depending upon the Boolean expression that you got, you have to draw. Means for this case, generally what I've seen is everyone are taking A as 0, 0 and B as 0, 1. So if you take like that, then you have to draw this one by using 2 flip-flops. Okay, but it will become redundant. Means repeated states will become, or else one flip-flop will be in off state. So better don't take like that. So almost everything will be same, but the thing is the state diagram will get changed, or else the flip-flop, the type of flip-flop that I've given to you will be different. So almost you can't find all the sequences in any textbook. So I've given the sequences like this. Suppose if it is 2-bit, how many sequences? 0, 0, 0, 1, 1, 0, 1, 1. Suppose if it is 3-bit, from 0, 0, 1. If it is 4-bit, 4 zeros till 4 ones. So here if you take, you will get 4 different sequences. This is 8 and 16. So how much? 16 plus 4, 20, 28. Okay, again this will depend upon the type of flip-flop that you are taking. How many flip-flops are there again?
4.
four flip-flops.
So 4 into 4,
DJ.
16.
16. Here also 4 flip-flops. 8 into 4,
32.
here again 16 into 4.
64.
64.
You try to add them. 64, 670, 80, 90, 122. So total these number of combinations you'll get. Okay, so individually I have assigned each and every problem to the different student. If I give the same problem for everyone, if one will do and everyone will copy from them. Okay, the same thing is applicable for Moore all. Next, any other questions still?
So tabulation methods.
You want tabulation method? Okay.
Sir, why we have to draw K-map for output?
Why we have to do K-map for output? For Mealy?
For both, sir.
Why? Because in Mealy, output is depending on what?
Okay,
Output is depending upon present input as well as present state.
Present state.
If
Yes.
you won't do it for output, then it is waste of studying both Mealy and more. Whereas for more, output depends only upon present state.
Yes, sir.
Okay, Quin-mcclusky, and this is also one of the default question, unit number 1. Unit number 1, this question will be there for sure, and from unit number 4, master slave JK. These two are the default questions, which generally I see in each and every paper. Okay, so tabulation method is also called as Quin-mcclusky method. So a sequence will be given to you, means a function. So how many variable K-map will you do for this?
5 variable.
5 variables.
5 variable K-map. So generally all the concepts that you have seen, like for 4 variable K-map also, you can apply this particular Quin-mcclusky method, you will get the exact answer. So earlier, suppose if there are don't cares, we are getting whether to group or not. So in order to get the conclusion that problems, you can do it by means of tabulation method, so that you will get the accurate answer without any errors. Okay, so simplify the following Boolean function by using Quin-mcclusky method. 5 variables are given, and these are the minterms or maxterms.
Minterms.
These are the minterms. So step number 1 is represent all the given minterms with their binary equivalents. So write the question, means 0, 1, 2, so on till 31. The thing which is given in the minterms, you write all the minterms and try to write the equivalent of size, how many bits? 3 bit or 4 bit?
5 bit.
5 bit.
5 bits, sir.
Why? Because 5 variables are there. So write the equivalent of 0. So it will be all zeros. Again for 1, it will be 4 zeros followed by 1. So this is simply the position weight I have taken here, 16, 8, 4, 2 and 1. So any doubts on this slide? Do you know how to write the equivalent of all the minterms?
Yes, sir.
So this is
Yes,
clear.
sir.
Next, step number 2, arrange the minterms in the form of groups. Means depending upon the number of ones, you need to group them. If you see 0, 0 has how many ones?
0
No
1.
one.
0 ones.
So 0 ones are there. Next, for 1,
1.
only
One.
single.
1 2 and
So 2 and 8, they will be having only single one within their equivalent. Similarly for 9, 17 and 24, only 2 ones are there. You can observe here. Only 2 ones will be there for 9, and for 17 only 2 ones, and for 24 also 2 ones. Similarly, arrange them according to the number of ones. 21 and 25 are having 3 ones, 15 and 27 are having 4, 31 is having 5.
5.
Clear till here?
Yes, sir.
yes sir.
Yes, sir.
Yes.
Arranging them according to the number of ones. Over. Now after this, what we have to do is we need to compare. See, this is orange colored and this is yellow colored. So compare these two now. So check the equivalent, means 0 1, next 0 2 and 0 8. So their equivalent should get deferred by only 1 bit position. So first what I did is I'm comparing this orange colored one with the yellow colored one. So different combinations are possible, like it is 0 1, 0 2 and 0 8. So 0 1, 0 2, 0 8. Can anyone tell me how I wrote this? What is the equivalent of
Only
0?
one difference is there.
0 equivalent 5 bits. So
0,
0 0 0 0 0. 1 equivalent.
0, 0, 0, 0,
0
1.
0 0 1.
1.
So if you observe here, there is no change. Here also there is no change. Here no change. Here no change.
Sir, if there is
Whereas
a
it is
change,
getting
there
deferred
must
by
be
1
error.
bit. So take an hyphen there.
Yes.
So 4 zeros hyphen. Similarly for 0 2. Correct?
Sir,
0 2
why
is it right?
the last but one position?
It is getting deferred only by
Sir, we
1
are
bit.
taking this only
Similarly,
for 1 bit difference, no, sir.
only for 1 bit difference we are checking. Next 0 8.
Second position.
Second position.
So here there is a difference. Whereas in all the remaining positions there is no issue. Okay. So we got 3 pairs from the first comparison. Next what I have to do? So till now I have compared orange with yellow color. This is 1. Now compare this yellow colored one with green and tell me how many combinations do we get. Yellow colored one with green. So here 19, 117, 124. 19, 117, 124. Similarly, 2, 9, 2, 17, 2, 24. Next, 8, 9, 8, 17, 8, 24. Try to find at least 1 bit difference should be there. How many pairs are possible which are having only 1 bit difference? So should I take 124?
No, sir.
124.
No.
So
No,
here
sir.
if you have the 1,
Three.
2, 3, 3 differences, so this is useless. Similarly, 2, 9. This is also not needed. 1 bit difference is not there.
217 also not needed. 224 not needed.
So I will
817
get,
is
8,
also
17
not.
also not needed.
so the required things I've indicated with the red colored here. So only these are the pairs which are possible if I compare
With only one
this
bit.
yellow one with the green. So in exam also better you try to write clearly or else you'll get confusion in comparison. Done. Next,
But we need
compare
to
this
combine with each and
Green
every
with blue.
green with blue. Compare green with blue and tell me how many combinations are possible.
6.
3.
1, 2, 3, 4. 4 are possible.
4.
So better you write for all the cases like this, or else you will get confused blindly if you try to compare, and if you write, you may go wrong. So this 921 and 2421 are not needed. Why? Because they are not getting deferred by 1 bit position. Over. Next, we are left with
Blue with pink.
Blue with orange.
2 in
okay. Compare
blue or brown.
2125 with 1527.
Only
bit
one
only.
is possible.
Only one is possible. Over. Next, last one.
Last
With
Compare
orange.
1527 with 31.
31.
There only 15.
Nothing is
27.
27 and 31. 31,
15,
yes, sir.
31 is
There's
possible.
2.
2 are
So these two
possible.
are possible. So overall, how many
Both
are there?
2.
So 1, 2. Here this is 3,
3,
4,
4,
5,
5, 6,
7.
7, 8, 9, 10, 11,
11 there, sir.
11.
12, 13, 14.
14.
So total we got
Total
14
14 are
pairs.
there, sir.
Now you may get a doubt like why I've taken a tick mark here. Can anyone tell me why I kept a tick mark? So see here 0, 1. Is 0, 1 covered? Yes, 0 is covered, 1 is
Yes,
covered.
sir.
Next 0, 2, 0, 8. So 0 is already covered. 0, 2 is covered, 8 is also covered. So put a tick mark. Next what is there? 19, 117. So better you make a note of this and tell me. 19, 117. 1 is already covered. 19 and 117 is also covered. Next 89, 824.
824.
89, 824 is also covered. Next 925, 1721. 925. 9 is covered. 25 is covered. 17, 21.
725.
17, 21 is covered.
Yes, sir.
Okay, 25 is already covered. Next 24, 25.
24 and
25
25.
is already
25 is
covered.
covered.
24 is
Already
also.
covered.
Next 25, 27.
27 is not covered.
25 is covered.
So 27 is covered. Put a tick mark. So last one 15,
15,
31.
13, 27, 31. 31 is already covered. 15 and 27. Take note.
So all the midterms are covered in the first comparison. Clear? So that's the reason I kept tick mark for all. Next. So finally take the answers that you got. So these are the possibilities. How many we got? 14, I think, right?
Yes,
Yes,
sir.
sir.
Yes, sir.
So
14.
total you write 14 in order. In the order that you have compared. Again, don't make a mistake here. If you observe here, in the first case is what? 0, 1, 0, 2, 0, 8.
So 1.
So 0, 1, 0, 2, 0, 8 is 1. So I have highlighted it with one color. 0, 1, 0, 2, 0, 8. Similarly, in the next comparison, we got 19, 117, 89, 824. In the third case, 925, 1721, 1725, 24, 25. And we got only 1. And here 2. Done till here?
Yes, sir.
Now tell
Yes,
me what
sir.
happened. Again compare this orange colored one with yellow colored one and tell me how many pairs we can do. Similarly, yellow with green, green with blue, and blue with a slight red. How should I compare now?
Sir,
0, 1, 1, 9.
that we have to take it
Well-
0 and 1s.
So you have to write like this now, 0, 1, 1, 9. Is it possible? One bit difference should be there. 0, 1, 1, 9.
No, not possible.
Next, 0, 1, 1, 17.
Not possible.
Sir, not getting, sir.
What you're not getting? Comparison.
Yes, sir. How are you comparing?
Okay, so better take individually. I'm taking orange with yellow. So compare orange with yellow. So 0, 1, 1, 9. Next 0, 1, 1, 17. 0, 1, 8, 9. Next 0, 1, 8, 24. So 0, 1. For 0, 1, what I got? 4 zeros, 1 hyphen.
One.
And for 1, 9. 0
Zero
hyphen.
hyphen double 0 1.
Is it getting default 1 bit or 2 bit?
Double 0 1, sir.
1 bit only, sir.
2. This is 0. Don't care. I mean 0 hyphen. So 2 bit position it is getting changed. So this is useless. Next check for 0, 1, 117. Again 4 zeros hyphen 117 is
Again.
hyphen 000 1. So see here in this 2 position it is getting changed. So this is useless. Next check for 0189. 0189. So 4
1
zeros
bit.
89. 89 is this one. So
It
0
is
1
possible,
0
0,
sir.
1, 0, 0.
It is possible.
Getting 2.
So this is possible. Only in this particular position it is getting changed. So I have taken 0189. Next check for 01824. 824. So hyphen 1 000.
Not possible.
It is
Not
changing here. It is changing.
3
So
times.
in this first comparison, only 0189 is possible. Clear?
Sir, means 0 and 1 is there, no, sir?
0 and 1 is one pair and 89 is another pair. Now you are trying to compare them to which should get default by one position. So only 0189 is possible. Why? See here.
Only
Here
one
it is
digit.
getting changed. Whereas these hyphens are same. So there is no change. So 0189 is one thing.
Okay, sir. Okay, sir.
Next, compare this yellow colored one with green and tell me how many are possible. Yellow with green. How many possibilities total? 19925. Next 191721.
1 9 17
It is
25.
not possible with 19920.
So in exam also like this, you need to compare each and everything. Almost 40 to 50 minutes this problem will take. So be careful while attempting this question. So 19 with all these 4 cases. Next 117 with all 4. 117 with 925. How many are possible?
For 1 9 9 25 is not possible.
Nothing is possible, sir.
This is not possible.
That is
19.
also not possible, sir.
What about 19 17 25? 19.
It is possible. Not possible. It is
19.
possible, sir.
Possible,
It is
sir.
possible, sir.
0-01. So
Sir.
how should I take this one?
Sir, 1 9
19.
17 25 is possible, sir.
Okay,
0
let me.
dash 001.
So 19 is 0 hyphen 001. 17
17
25.
25. 1 dash
1 hyphen
001.
001.
So here this is changing.
Only
Okay,
one is different. It is possible. Only
this
that
is
is
possible. Correct. 19 17 25 is possible. Similarly 8 9 24 25 you check.
8 9 24 25. Yeah, so one bit different. First one 0 and 1.
Is there any other possibilities or only these two?
No,
So done.
no possibilities.
Next, compare green with blue.
Green with blue.
9 25 25 27.
Not possible.
Nothing is
It is not
possible.
possible.
Not possible,
Nothing
sir.
is possible. Okay. Next, blue with red. 25 27 with 1531.
Nothing is
Not
possible.
possible.
Not possible.
This
Nothing
is
is
also
possible.
not possible.
Over. So now let us put a tick mark now. How many are covered? Let me check.
1
So we
9
got 0189.
8 9.
0189.
0, 1 is covered and 8, 9.
8, 9 is
Okay.
covered.
Next, 1, 9, 17, 25.
1,
1,
9,
9,
17,
17, 25.
25.
Next,
Next.
8, 9, 24, 25.
8, 9, 24, 25.
24, 25. Now, what about this remaining? How will you check?
Not covered.
Are they not covered, or else internally also do we need to check?
Internally, we have to check, sir.
Check internally and tell me, is 0, 2 present in the equivalents that we got? So,
0.
what we got is 0,
Not
1,
present, sir. 0 is
0.
present,
Okay.
but 2 is
0,
not.
1, 8, 9.
Okay, next one is 1, 9.
1, 9, 17, 25.
Okay, third one is
8,
8,
9,
9,
24,
24,
25.
25.
24, 25. So, let me check. 0, 2.
0
Okay,
is
0 is not there.
present. 2
0
is
is
not.
present. 2 is not there. So,
0,
I'm
8
putting
is present,
next one.
sir. 0, 8.
Okay, 0, 8 is present. 117. In this 117 is
Yes,
present.
sir. 117 is present.
Next, 824.
824 is also
Yes, sir.
present.
824 is present. Okay.
925 is also
925 is also present.
Okay. 1721.
1721 not present.
No, sir.
25, 27 not present. 15, 31 not present.
25, 27 is not there. 15, 31 is also not there. 27, 31 is also not there.
So this is how we need to put the tick mark. So in order to make it clear, I have assigned some variables for this as P.
Q,
This is
RST.
RST. Any variables you can assign over. So what we got is, after comparing this, we got three combinations, that is 0, 1, 8, 9, 1, 9, 17, 25, 8, 9, 24, 25. So if you compare them again, is there any possibility of minimization?
No.
No. So leave till here. So they are unique. So assign some variables for them as U, V, and W. Now how I wrote this one, can anyone tell me now? So 8,
Here
9, 20.
8, 9, 24, 25. In this table, you cross those numbers.
Okay, we got this UVW. So I wrote UVW and followed by PQRST. So
PQ,
PQRST
RST.
is nothing but 0 to 17, 21, 25, 27, 15, 31, 25, 27, 31. You write the leftover things here. That's what I took here. See here. PQRST followed by UVW. We can call them as PI, prime implicants. Now, this is nothing but the min terms which is given in our question. In the starting, these are the min terms. So 8, 9, 24, 25. Put a cross mark at that point. 8, 9, 24, 25. Similarly, you fill for 1, 9, 17, 25, 0, 1, 8, 9, 27, 31, 15, 31, 27, 25, 17, 21, 0 and 2. Now, after putting this cross mark, what we need to check is within a single column, only one single cross mark should be there. So here, only single cross mark is there for this column. So put a circle. Next. In 15th column also, only one cross mark. In 21 and in 24. Any other possibilities of only one cross mark in a column?
No, sir.
No, sir.
So this cross mark is for 0, 2. And this cross mark is 17, 21. This is 15, 31. And this is 8, 9, 24, 25. So we can call them as EPIs. What is EPI?
Essential prime implements.
So they are called as essential prime implicants. So our answer will be 0, 2. How I got this answer? 0, 2. 0, 2. What is the equivalent of 0?
0, 0, 0, 0, 0.
So this is 0, 0, 0 cross 0. First one is for A. So 0 is nothing but bar. So A bar, B bar, C bar,
C bar,
E bar.
E bar.
Tell me for 17, 21. How I wrote for 17, 21?
17 equivalent and 21 equivalent.
Okay, equivalent of 21. So this is 16. 16 plus 4, 20, 21. So this becomes 1, 0, hyphen 0, 1. How should I write?
0, 1. A,
A,
B bar,
B bar,
D bar, E.
D bar, A.
A, B bar, D bar, E. Similarly, you write the answers. Okay, so till here, if you write it, it will be more than enough. So almost what are covered? P, Q, H, W is covered. P, Q, S, W is covered. Now you check for remaining these 4. Again, you write them in a table and try to check if there is only single cross mark within a column. So the leftover thing, again, I wrote it in the form of table and I'm checking for the column which contains single cross mark. So from that, what I got is U is getting covered, V is getting covered, and T. So R is not needed. So how will you write the answer for this now? For V, you tell me how will you write the answer? For 1, 9, 17, 25, what will be the answer? And for 0, 1, 8, 9, what will be the answer? 27, 31, what will be the answer?
Sir, instead of writing equivalence in the table we wrote, no sir. We compared them and wrote them.
Directly we can write the answer. So here I'm writing once again, but already we did in the previous cases. So by seeing there also you can write the final answer. But this is the procedure.
Done.
So this is a big lengthy problem. Concept is same for all the models. Just the thing is comparison, everyone will do a mistake. If you even miss a single comparison, then your answer will go wrong.